So the goal of this video is going to be to review how to solve a system of linear equations. And there's two ways we can do that, by elimination and substitution, and we're going to review them both. So our goal here is to solve the following system. We've got two equations, 2x plus y equal to -3, and 3x minus 2y equal to -8. All right, and we're asked to solve the system. So what does it mean to solve the system, first of all? So we're looking for an x and y value that satisfy both of those equations. In other words, make each of those statements true. And graphically what we're doing is we're finding essentially the ordered pair, or the point, where those two lines intersect. Okay, that's really what we're doing when we're solving the system. But algebraically, we're just trying to find an x and a y that satisfy both of these equations. So with the elimination method, the goal there is to add these equations together such that one of the variables cancels out, and we're left with an equation with one variable. So if I do want to get a variable to cancel, I'm tempted to get the y's to cancel by multiplying the first equation by 2, right? Because then I'd have 2y minus 2y in the second equation. If you wanted to multiply them both by something to cancel the x's, you could do it. You could multiply the first one by -3 and the second one by 2, right? You'd have -6 plus 6, and that would do it. But that's a lot of work. I'm tempted to just multiply the first one by 2, so we'd have 2x, 2 times the quantity 2x plus y equal to -3 times 2, right? What you do to one side, you got to do to the other. Okay, so if we distribute that through, we'd have 4x plus 2y equal to -6. Okay, and what was the other equation I had? It was 3x minus 2y equal to -8. Okay, so now if I add these together, 4x plus 3x is 7x, right? 2y minus 2y is eliminated, right? And then -6 minus 8 is -14, okay? So with 7x equal to -14, I am going to divide both sides by 7 to get x by itself. So x is equal to -2. Okay, so if x is equal to -2, I can take that knowledge and put it into one of the two equations that we started with to get the y value. So I'm just going to put it into the first one here. I've got 2 times -2 plus y is equal to -3. So -4 plus y is equal to -3. So I want to solve this for y, so I'm going to add 4 to both sides. -4 plus 4 plus y is equal to -3 plus 4. What's -3 plus 4? Well, +1. Okay, so I'm looking at the ordered pair based on this knowledge of getting -2, 1, right, as a solution to this, right? So before I say that that's the solution set, I want to do a couple of things. First of all, this was the elimination method. I want to try the substitution method too, see if we get the same thing. Okay, so with the substitution method, the idea is to take one of these equations and solve it for a variable, and then stick what you know about that into the other equation. So, for example, between these two equations that we started with, I would solve the first equation for y, because it doesn't have any leading coefficient on it, so the arithmetic there will be very, very easy. So if I take 2x plus y equal to -3, and I want to get y by itself, so I'm going to subtract 2x from both sides. So 2x minus 2x plus y equal to -3 minus 2x. So y is equal to -3 minus 2x. Okay, so now that I know that y is equal to -3 minus 2x, then I can stick what I know about y into the second equation. So 3x minus 2 times -3 minus 2x is equal to -8. Does everybody see what I did there? So I just took what I knew about y and I stuck it into the second equation for y. Okay, and what that did is it gives an equation just in terms of x, right? So I want to get rid of the parentheses. That's the first thing. I'm going to distribute -2 through. -2 times -3 is +6. Negative 2 times negative 2x is positive 4x, equal to negative 8. Okay? Combining like terms, 3x and 4x is 7x plus 6 equal to negative 8. I want to get 6 over on the right-hand side, so I'm going to subtract 6. 7x plus 6 minus 6 equal to negative 8 minus 6. 7x is equal to negative 14. Okay, and if we divide both sides by 7, x is equal to negative 2. Okay, how are we doing so far? Is that what we got when we use the elimination method? Yes, we got that x is negative 2. And now we would want to plug negative 2 into the first equation, or either one of the equations, and solve it for y. So I would have 2 times negative 2 plus y equal to negative 3. Negative 4 plus y is equal to negative 3. And so we would want to add 4 to both sides to get y by itself. Yeah. So negative 4 plus y is equal to negative 3 plus 4. Negative 3 plus 4 is positive 1. Okay, so did we get this same solution of negative 2, 1? Yes, we did. Okay, now how would we check that? Let's check our solution. Both with elimination and substitution, we got the same answer, so it's reasonable that it's going to be correct. But we want to stick in values of negative 2 for x and 1 for y in both of these equations. So in the first equation, 2 times negative 2 plus 1, right, since y is 1, is equal to negative 3. Is that true? Well, negative 4 plus 1 is negative 3. Yes, it is true. Okay, and how about in the second equation? So we'd have 3 times negative 2 minus 2 times 1. Is that equal to negative 8? Well, we'd have negative 6 minus 2. Is that equal to negative 8? It sure is. So the x and the y value that we found has to together make each of the equations that we were originally given true statements. Okay, so the solution set is negative 2, 1 as an ordered pair. Okay, so this is just a good review of how to solve a system of linear equations, both using elimination and also using substitution. We did this in both methods. We got the same answer, and it also checks out.